Welcome to my channel WinChem. Today we are going to see a proton NMR spectroscopy, which is highly useful for those who are preparing for PGTRB and Polytechnic TRB. Some of the tricks I have given and problems also solved over here. Let's see what are all the tricks. What we need to keep it in our mind. Okay, some of the ranges we need to keep it in our mind. And which is a downfield and which is a upfield and which is shielded and deshielded, the shielding, frequency, everything we need to know. See here, this is a small value, chemical shift. According to the chemical shift, this is a small value and this is a large value. Okay, and this we call it as upfield. This side we call it as upfield and this we call it as downfield. Okay, and the frequency here is very low frequency, but here the frequency is high. And the shielding, according to shielding, this we call it as deshielded and this is a shielded. So SS small shielded, here a large deshielded. Okay, large and deshielded. And some of the values I've given here. See here, this is a TMS. So this is the standard one, which is comes as 0. So next to that, whatever the saturated hydrocarbons, okay, whatever the saturated hydrocarbons, whether it is a CH, CH2 or CH3, that comes in this range only, this green range only. And if this CH2 and CH3, that is 0 to 4.5 range, if this is attached to some of the oxygen, next to oxygen is there, means then you will get the range of 3 to 4.5. If it is not attached to any electronegative atoms, then the range with is below a 3. Okay, all these will below 3. So this you need to keep. And if any alene group is there, then 2 hydrogens are there. Okay, split into 2 hydrogen, and these 2 hydrogens will come in the range of 4.5 to 6.5. And if aromatic region is 6.5 to 8.5, the aromatic hydrocarbons, all the hydrogens in the aromatic, it comes around 6.5 to 8.5. And if any aldehyde is there, this hydrogen it comes around 8.5 to 10.5. Okay. Here we are going to see if the methyl group is attached to some of the electronegativities, okay, then what will be the range? This you need to keep it in your mind, okay. These are all the electronegativities. See, from the lithium till the fluorine, the electronegativities keep on increasing. If you see the periodic table also, the carbon, nitrogen, oxygen, fluorine, the electronegativities keep on increasing from left to right, okay. Here they are saying in the reverse manner they have written over here. See here, the lithium, the electronegativity is 1 and silicon 1.9, carbon 2.5, nitrogen is 3, oxygen is 3.4 and fluorine is 4. So according to that, the range is also keep on increasing. So this is trimethylserine is a standard one, so it comes as a 0, and the next to that, see here, only carbon is there. So here also carbon, so it's around 0.9. Okay, if CH3 group is there, means without any substituent of that, then we will get 0.9. If nitrogen is attached, then it becomes 2.5. If oxygen is attached, it becomes 3.5, and if fluorine is attached, and it becomes 4. So according to that electronegativity, this range will also increases. And see here, if chlorine is attached, if this is a 1 chlorine is there, okay, this methyl chloride, 1 chlorine is attached, then this CH3 group will come around 3.06. If 2 chlorine is attached, this is dichloromethane. If 2 chlorine is attached, then it is 5.3. See here, 3, 2, 5.3 and 7.27. Here the 3 methyl group is there. This we call it as chloroform, CHCl3. Trichloromethane here, 7.27. Keep on increasing. Keep this point. This is the solvent which is used to dilute the compound. Okay, this is solvent peak. Usually comes around 7.27 chloroform. We will see one by one all the problems. The first problem is this one, TBME. Okay, this is a tertiary butyl methyl ether that we call it as TBME. Here we have to segregate the hydrogen in a different way. If the hydrogen is in the same environment, we can keep it as a one type, and if it is in a different environment, we keep it as another type, another one. Okay, we can mark it as 1 and 2. So if you see this CH3 attached to the carbon, this CH3 attached to the carbon, which carbon is attached to the oxygen. So if all the 3 is having the same environment, so we have marked these 3 as a green color. Okay, so how many hydrogens are there? 3 plus 3 plus 3, 9 hydrogens are there. All the 9 hydrogens will come as a one signal only. Okay. and this CH3 will come as another signal. So we will get only two signals are there. See, the first one, this three signals, how many? 9 hydrogens. This 9 hydrogens will form a singlet. Okay, here there is no hydrogen is there. If this hydrogen, this, okay, if 3 hydrogens nearby is carbon which is having a hydrogen means number of hydrogen we need to check. According to the number of hydrogen plus 1 you need to add, that will call it as a splitting. So that will comes as a splitting. Here there is no hydrogen is here. The carbon is having a 4 valency, 1, 2, 3, 4. No hydrogen is there here. So here there is a no splitting. Okay, only singlet is there. Okay, only carbon, there is no signal. So 1, 0 plus 1 is 1. That is singlet is comes. Okay, so 9 hydrogen singlet and in the range of 1.1 ppm. Here, see here there is a no hydrogen in the same way. So what will be there? 0.0 plus 1 is 1 singlet, and this hydrogen comes around 3.1. Why? It is directly attached to the electronegative oxygen atom. So it comes as a 3.1. Next problem. See here, I have segregated all the different hydrogens. These three and these three are in the same environment. As I said in the earlier, this tributyl are in the same tertiary butyl will be in the same environment. And in the aromatic, 2 hydrogen is also at the same environment. Nearby tertiary butyl, and the center methoxy group is there and the alcoholic group is there. So it is the same for these two also. So this also I mark it as the same. And this is different and this is also different environment. We'll see the range for all these things. Okay. These 9, see this 9 plus 9. 9 plus 9 is 18. This 19 hydrogen comes as a singlet because it comes with the C only C is there. So singlet with 0.9 ppm. Okay, these are all 9 ppm, 0.9 ppm. And the next one is this aromatic hydrogen. As I said earlier, this aromatic hydrogen is usually comes in the range of 6.5 to 8.5. So here it comes around 6.8 ppm singlet. Okay, then 2 hydrogens are there. And this CH3 which is attached to the oxygen, so it comes around about 3. Okay, so 3.8 singlet and 3 hydrogens are there, and only 1 hydrogen which is attached to the oxygen, so which is directly attached to the oxygen, so 5.4. But here it attached to carbon and then oxygen, so it is 3.8 directly attached to the oxygen, so it is 5.4 ppm singlet and 1 hydrogen. That is for 1 hydrogen. And for the problem 3, see, this is the compound. We need to say what are all the things will be there. First you need to see how many methyl groups are there. That is the easiest way to find out. If values are given, they are asking which value is close to this structure. They are asking means you need to see how many methyl groups are there first. 1, 2, 3. 3 methyl groups are there. Okay. So 3 hydrogens are there. Okay, 3 hydrogens. Here also 3 hydrogens. 3 hydrogens are there. It's easy for you to find out 3 hydrogens first. Okay. See the first 3 hydrogens. This will come around this or the same environment. Okay, as I said in that earlier, is also same environment. Both are attached to the C carbon only. There is nothing is there. Okay. So both will have 1.4 ppm. The 6 hydrogens are there. And the next one it will be 1.8 ppm, which is attached to the carbon attached to the double bond. That's why let's slightly increase 1.8. Okay, 1.8 ppm 3 hydrogen. And the next one is this is CH2. Next 2 hydrogens are there. Here 2 hydrogens are there. Here 1, 2, 3, and here 1 hydrogens are there. Okay, here 1, 2, another 2 hydrogens are there. Here 2 hydrogen. This 2 hydrogen comes around 2.9. This is CH2. Okay, so there is a no double bond. So it's actually 2.9, below 3 only. But here a double bond is there. Okay, so what will be the value? It will be the above. This is a 5 point. This is the alkene group is there. So 5.6 ppm, and that to 1 hydrogen. Okay. Problem is, see here, this is the compound. Okay. In this compound, if you see this, you can get 1, 2, 3, 4. Okay, 4 hydrogen, 4 ways of hydrogen is there. You need to segregate which is similar or different that we need to segregate. See here, this is attached to nitro group, but this is attached to methyl group. So these two are different environment. Okay, and this CH2 is having different environment, CH2, CH3, here CH2, NO2. So 4 values will come over here. And first 3 hydrogen we need to take it out. 3 hydrogen, and here CH2 is there. So CH2 is there. 2 hydrogen plus 1 triplet. Here what is the value we will get it? 0.973 hydrogen, and it becomes a triplet. And coupling constant is 7. Okay. And in the same way, here if you see that here 2 hydrogen is there, here 3 hydrogen is there, 2 plus 3, 5, 5 plus 1 is 6, sextet will come here, CH2. For 2 hydrogen, sextet will be there, and the value is 1.42. This is the splitting pattern. How to find out the splitting pattern? You have to add nearby, you have to check the nearby hydrogens. You have to add it. Here 3 is there, here 2 is there. Overall 5 hydrogens are nearby for this carbon. With that we need to add plus 1. So 5 plus 1 is 6 sextet. And the next one, see here is CH2. Here 2, 2 plus 2, 4, 4 plus 1, 5, 5 is quintet. Quintet is there, here 2 hydrogen is there. For this is 2, value is 2, and for 2 hydrogen, quintet, coupling constant is 7. And for this, here 2 is there, 2 plus 1, 3, triplet is the splitting pattern. For the 2 hydrogen, the value is around 4.4. Why? This is attached to the nitrogen atom. Attached to the nitrogen atom is 4, which comes around 4. Keep that in mind. So slowly, I'm keep on going the advanced problem also. See, try to finalize this. And in the same way, these two are in a similar environment. These two having a same one, and this is different. And these two are slightly similar, and it's not completely similar. Slightly showing a similar. Okay, so overall, how many signals you will get? 1, 2, 3, and 4. These two are nearly the same only. Okay, these and this will comes around 1.08. Usually before 0.9 used to come, methyl group. But here the carbon which is attached to the nitrogen, so it slightly increased to 1.08. And see the number of protons, then easily take it out. This is the value for this methyl group. So 6 proton is there. Here 3 proton and here 3 protons. 6 protons, 1.08. And this is having a 1 hydrogen. So 1 plus 1 is a doublet. Doublet for these 3. These 6. Okay, doublet. Coupling constant is 7. And for this hydrogen, see here also 3. Here also 3. 3 plus 3, 6. 6 plus 1, 7. So 7. So what will be the thing? Here the coupling constant J is equal to 7 Hertz. And 1 hydrogen, it comes around a 2.93. This comes around 2.3. Why? This is directly attached to the nitrogen atom. That's why it's close to 3. Okay, and it's close to 3. And the next one is this 2 CH2 group, and here, sorry, 2 CH2 group. Here also 2 CH2 groups are there. So here, how many hydrogen is there? 2 plus 2, 4 hydrogen. Here also 2 plus 2, 4 hydrogen. Both is having a value 2.45 and 2.8, nearly close to that. Both are having a triplet. Both are having here 2 plus 1 triplet. Here also 2 plus 1 triplet. Okay, this is the value for this problem number. See, now a self-practice problem. 2 problems are there. Okay, just analyze these 2 compounds and find out the values for these 2 compounds. And some of my friends are keep on asking about Polytechnic and PGTRB organic problems. We will upload soon. In the next videos, we will concentrate on that and we will upload soon. Thanks for watching. Subscribe my channel and click the bell button so that you will get upcoming videos and share to your friends also. Thank you so much.